Hello everyone, in today's video I would like to talk about the MATLAB scripts for generating the control charts. And firstly, let's go through the example for generating the P chart, which is used to monitor the proportion of defective unites when the sample size is fixed. The vector x contains the number of defective items found in each sample. In the function, we set the size of the inspection unites to a constant value 200 with the typed in unite and 200. For each data point, pi equals to xi over 200. For the center line, p bar equals to the sum of xi over the sum of ni. And in this case, ni is a constant value 200. For the upper control limit and the lower control limit, MATLAB calculates with formula, um, which is same as what we have learned in the lecture. The UCLPI and the LCLPI formula indicates that they are the constant value because Ni is constant. From the figure, we observe 1 point above the upper control limit and 1 point below the lower control limit. This represents special course variation, meaning that at those symbols, the process performance significantly deviated from expected binomial variation. Therefore, the process is not fully in statistical control and those samples should be investigated. Okay, next, we will go through the script for generating the NP chart, which is used to monitor the number of defective unites when the sample size is constant. The vector x contains the number of defectives observed in each sample. Similarly, we set the size of the inspection unites to 100, with the typed in unite and 100 here. The blue data points are simply xi, and we firstly get the p bar equals to the sum of xi over the sum of ni. Then we can get the np bar equals to n times p bar, which is shown as the green center line. For the upper control limit and the lower control limit, we can get from the formulas, um, like here, the UCL and the LCL for the NP control chart. From the figure, we observe 1 point exceeding the upper control limit. This point is marked as a violation and indicates special course variation. That this sample has an unusually high number of defectives compared to what would be expected under binomial variation. Therefore, the process is not fully in statistical control, and that sample should be investigated. Next one is the script for generating C control chart, which is used to monitor the number of nonconformities when the sample size is constant. The vector C contains the number of nonconformities observed in each sample. Each value represents the total count of imperfections found in a fixed inspection area or fixed number of unites. In the function, the parameter unite 50. The unite 50 specify that each observation corresponds to 50 inspection unites. In the generated figure, the green center line means the C bar, the average of all defect counts. Then the control limits are calculated using the Poisson-based formulas. Yeah, it's right here. The UCLX and the LCLX for the nonconformities control chart C chart. And from the figure, we observe 1 point exceeding the upper control limit, and 1 point falls below the lower control limit. These are marked as violations, indicating special course variation. This suggests that at those particular samples, the process behavior deviated significantly from the expected Poisson variation. Therefore, the process is not fully in statistical control, and those samples should be investigated for assemblable courses. Finally, let's talk about the U-control chart, which is used to monitor the number of nonconformities per unit when the sample size varies. The vector U contains the observed counts of imperfections for each sample, while the vector N contains the corresponding number of inspection units for each sample. In the function, the first argument, U, is a vector for defect counts, and the parameter unit and uncolon is critical. It provides the sample size for each observation. The notation uncolon converts the vector n into a column vector, ensuring MATLAB treats each element as the inspection size corresponding to each defect count. In the figure, the green center line U bar equals to the sum of Ui over the sum of Ni. We get the control limits based on the Poisson model assumption. Since the sample size vary, the control limits are not constant across all points. For every value of UCL and LCL, we calculate with formula like this. And visually, every blue data points are within the control limits. This indicates that the process is fully in statistical control. Yeah, that's it. Thank you.